Hey there and welcome back to the Code Wrinkles channel for a brand new video. Minimal API is one of the most important new features in .NET 6, I would say, and the reason why I say this is because it actually provides us with a new way, a new model to design our API, starting of course with .NET 6. But don't get scared if you didn't try it already, because we got you covered. In this video, we will have a total or a full getting started guide on how to get going with the minimal API in .NET 6. So let's start already from scratch. And this is an important thing, because when we want to create a minimal API, I just also want to show you how we can go about this in Visual Studio if we want to create a new project. So let's just click here on a create new project. And of course, what we have to choose is the ASP.NET Core Web API template. If we click next, of course, we have to provide a name here, and let's call this minimal API demo, and then click on the next button, of course. Now here is where we have to be a little bit careful, because if we want to create a new minimal API application, there is this checkbox here that needs to be unchecked. And here the text says use controllers and uncheck to use the minimal API. So we have to make sure we uncheck this checkbox before we actually create this new project. There is, however, one important thing. So this is how we do it when we start the minimal API from Visual Studio. However, even if you start with the controller-based application, this is not a problem because it's actually very easy to turn your regular controller application into a minimal API just by tweaking around with the program.cs file. And we'll look into this just in a second. Now let's click here on create. And after a few seconds, I would expect that our minimal API project should be created. And here it is. Voila, we have already a minimal API. Now let's take a look at what it takes actually, or what a minimal API looks like. Now here we have a totally new startup model in .NET 6 for ASP.NET Core applications. But I really don't want to get too deep into how the new startup model looks like, because we already have created a video on that, and I'll leave a link to the video in the description of this one. And you'll probably see also a card somewhere here on the screen that will point you to the video where we actually discuss in depth how the new startup model works actually in .NET 6 for ASP.NET Core applications. So we won't look into that. But I want to look at the things that actually make this project to be a minimal API. Now, one of the important things here is this service that we add, which is Add Endpoints API Explorer. Now, this is not really or necessarily only for minimal APIs, but it is a new way in .NET 6 to actually describe metadata about endpoints, and these services then are responsible to retrieve and get that metadata that we define for those endpoints in order to work with it in different circumstances. One of it would be to further configure how a Swagger should look like, and how we would map different parts of our application to the Swagger documentation. So this is one first important thing here. But the next one, if we look here in the second part of this file, so we already have a web application because we have built, or we have run the web application builder. So we get an app back, of course. And here we see that we can configure our middleware. We use Swagger and Swagger UI if the environment is development. Then we use HTTPS redirection, which are typical middleware that you see in most ASP.NET Core applications, also in previous versions of .NET. But then you can see already we have this app MapGet, and then this weather forecast. So if we would run our API right now, this is the exact same concept of a template like we also had in the previous .NET versions, but in this case, you can see that it is mapped here directly in the startup of the application using this MapGet. Now, if you are familiar with Express.js and maybe also Java Spring Boot, you would see that there are a lot of similarities with how you would configure an application in Express.js, because it's exactly the same way. you have something like a builder where you add different type of configurations to your applications. You then add middleware. You then add your endpoints with methods that are very, very similar to this, like get, post, put, and so on. And then you run the application. And here you could also specify, for instance, something like, I don't know, a port or a URL on which you want your application to run. So that's basically it. This is what a minimal API is all about here, this app MapGet, and the way that we can simply map our endpoints directly by providing a pattern and then basically providing just a function, a method that can be executed and that could return something. Now we will look deeper into what exactly do we return when we have a .NET 6 minimal API. Now, the next thing that I would like to actually go into is, of course, this seems to be very, very interesting, but of course you would say that this program.cs file will get very, very messy, very, very short, and you are totally right. And there might be some techniques that we could use to actually keep this file clean, but I would also don't like to go into this topic because we already had a video that was actually a live coding session on that. And I will also leave a link in the description of this video to that, so you might want to go and check it out. But why is actually this minimal API so important from my point of view? Well, because as we see, it's actually minimal. This doesn't mean that it is simplistic. It does mean only that it is less opinionated than the regular controller-based approach. And why do I mean by that? Now, when you use frameworks, we used to say that they are opinionated, and we say that because frameworks provide us with a certain work type. So they provide us with certain steps that we have to follow in order to get the application running using that specific framework. Now, in ASP.NET Core, this type of workflow, I would say, usually when it came to API, it did include controllers and everything that comes around with those controllers, how dependency injection works in controllers, and all the things similar to that. Now, this would also make it for us developers, let's say, or would define for us developers like a clear path on how we should structure our application or how we should structure our software when we use ASP.NET Core. Now, with the minimal API, as .NET 6 provides us just with this simple way to provide an endpoint and to run an endpoint, it actually gives us a lot of freedom on how we actually want to organize our application, how do we want to structure it, and how do we actually want to run it. And from my point of view, this makes it very, very easy to go to a full CQRS approach using probably Mediator, in which you could simply use command queries and the handlers for them, and that would decouple your application a lot. And this could also go one step further towards what Jimmy Bogart calls a vertical slices architecture, where we organize, for instance, our API by features, not by conventions like folders, like controllers, services, and things like that. We just have features. Now, in this video, I won't go deeper into how we could create a vertical slices architecture using this minimal API. That would be a topic for a different video, so you might want to check back here from time to time to see if we published that video already. But I just want us to get started. And before getting started, I just wanted to have a better understanding on why actually this approach with a minimal API is, in my opinion, very, very nice for us developers, because it offers us a lot of freedom to design or to structure our application the way we see fit, and it doesn't impose us opinions on which workflow should we actually follow and basically which architectural pattern. So yeah, that's mostly it. Let's now go here and take a look at what we already have. We have just an endpoint from the template, but what I want to do here is I want to implement a full CRUD or a full list of CRUD operations on a certain entity. And for that, I have already configured my application. So a very basic configuration. We have here a model, which is a payment, which has some properties. We have the DbContext already created. And that's kind of it. We also have created, or we have added this connection string section to the app settings.json file, and that's basically it. We'll take it from here. Now, the first thing that we need to do here is, of course, register our DbContext. And of course, one way to do this would be just the regular way that we used to do in regular ASP.NET Core applications, only or with the only difference that in this case we should actually register our services right here. So let's get started with it, and let's have a variable which we call connection string, and that would be equal to builder. And all the builder, we have the configuration object, and here on this configuration we have this get connection string method, like we used to also have in the startup class in ASP.NET Core. And once again, I have a full video that talks about all the different ways we can configure our application in this new startup model that we have in .NET 6. Because by the way, the startup model is exactly the same for all the applications. So both for regular MVC applications or controller-based APIs, the model or the startup model is exactly the same. We have only one program.cs file. We don't have a startup.cs class anymore. So we have to configure everything here right now where we are. And once again, we already have a video for that. And if you watch it, you can you will get more deeper insights about all the things that we can configure here and how we can fully configure our host, web host, and services and middleware and everything around our web application. Now, for the connection string, I have here this default. So here we should have already the connection string. And then we can simply go on the builder. We have these services, and then we can add DbContext. Everything works exactly like we did in configure services in startup, but here we do it directly on builder and services. Of course, this method comes from Entity Framework Core, and it takes an app DbContext because this is how we actually called our DbContext. We need to add some using, and maybe at the end of the video we'll do some funky stuff with all the usings here that we will add here to this file. Now, of course, here we would have to provide some options. Of course, in the options, we want to tell that we want to actually, let's call this options. I guess it should be right, DbContext options builder, and let's use options and then use SQL Server. Here probably we'll need to add another using, but before we do that, let's simply add the connection string, and then also let's add the using. And now I guess we should also add Entity Framework Core, and that should be it. So that's actually everything that we needed in order to create our DbContext. Now, since we just added our DbContext, we have the model, we have everything going, we have the connection string, but we haven't created a migration and an update to the database. So let's head over to the package manager console, add migration initial. That should add the migration for my application, and then we could run the update database command. So for now, everything's okay. We have the migration. Now let's run update database, and that should create our database right now, and everything seems to work fine. I don't bother to check if the table was created because I'm sure that everything's okay. Since we have just one entity, we don't have any relationship, so everything should work just fine. Now we have set up everything. We have also seen how we can add services to our web application here by using all the old ways we actually use to register services, but we do this on the builder and the services property. And that's basically it. Now we should be able to get going. Now, first of all, what I want to do, I would really like to actually get rid of everything that we have here from the template. So we have this app MapGet. Let's get rid of that. We'll add our other endpoints here, and we'll also don't need this weather forecast model because we will run we will use our own model. So now let's get started to design our endpoints in the minimal API of the .NET 6. And let's start with a get for the list of all the templates. Now let's see app.mapGet, and you see that this method name is actually very clear in regard to what exactly do we want to configure, because we want to map a get method. Then we would have the MapPost, MapPut, and MapDelte. So it's fairly clear from the beginning exactly what we actually need to provide. Now, when we want to add an endpoint to this minimal API, there's actually two things that we need to provide. The first one is the pattern. that the application should look for when a request comes in to resolve exactly which action should be triggered. Now, our pattern here would be simply API.payments. So when we get a GET request for API/payments, then we should do something. What should we do? Well, that's exactly the second step that we have to provide here. And this is actually, we need to provide, or we can provide, we will look also in different ways in how we could do that, but we can provide here basically a Lambda function that we can execute and return different things. Now, one very important thing here is, because right now, once again, this is not a video about programming best practices, but it is a video to understand how the minimal API works. And one of the scenarios that we have is, okay, how can we get dependency injection running here? Because of course, when we want to handle this GET request, we might need an instance of the app DbContext. Well, no problem. Dependency injection is very, very easy here in this minimal API because you can just inject everything here. So I would say that I want to inject an app DbContext, like it was called. Let's call it CTX, of course, our context. So that would be it. And there's actually nothing that I need more here. What I can do here is, let's have our payments. And here in these payments, we just await context.payments, and we call toList async. Of course, we want to do everything asynchronously. And once again, in most of the code samples that you will see online in other videos or in documentations, everything is synchronous. And I totally hate that, because in real life application, we'll always work with async and await. So why not then include in all the documentations and the videos already endpoints that implement this async and await, so that everybody sees exactly how this can be done, especially since this is a very new model of designing our API. So let's we get here our payments, and now we need to return something. In regular ASP.NET Core applications, in our controllers, we usually use this iActionResult, or the task of an iActionResult. Now, in the minimal API, we don't have this concept of iActionResult, but we have the concept of iResult. Of course, we cannot simply return an interface right now, but we have then a class which is results, and that has some static members that we can invoke. Actually, those are static methods, and they are very similar to what we used to have, or to what we still have actually, in the iActionResult. In this case, we just want to return an OK, and we return a list of payments. Now, once again, here in this case, we just return our domain model. In a real application, you would probably use AutoMapper in order to map to DTOs. But once again, I just want to focus right now on how this minimal API works. And this is not a video on best practices on creating APIs in general. So this is why we just return the payments here. And that's actually it. So right now we have done everything. Now there's one more important thing or point that we can cover here is when we use this type of minimal API with the map methods, we can specify some metadata about this endpoint using methods. For instance, we can say here with name, which should describe a unique name for this endpoint. Let's call this get all payments. For this specific endpoint where we get a list of payments, maybe this is not something that it is very, very important, but for other endpoints, it would be. Because for instance, when we create a get payment by ID, then we'll probably want to return a created, and we want to return a created at route so that we provide to our consumer of the API also the route in which or with which it could access the newly created resource. So in that case, we will see that we could use this name that we provide here. Of course, we have here different methods like with display name. The display name can actually it has no constraint to be unique. You could use the same display name for different type of endpoints. And once again, if you watch my live coding sessions that are, by the way, here on the YouTube channel, you will see that we have used this type of metadata in order to instruct Swagger how it should actually organize all the endpoints on the Swagger UI. Now, we won't get deeper into this, but we can also add things like produces, that we can specify what exactly do we produce. For instance, we produce a 200 result, but we could even produce, for instance, a 500. And more than that, maybe we can say we can use the generic produce, and we can say that we can produce here a list of payment. So all this type of metadata is important because it actually describes your endpoint and what it is meant to do. And on this metadata, there are other parts, either of .NET 6 or of external libraries, like we have Swashbuckle, that would rely on that to actually read more information and know exactly what your endpoint is all about. So you can use simply this metadata methods to set actually information about what your endpoint actually intends to do. So that would be actually it for this MapGet method. Let's leave here a little bit of space, and let's just go then here to the next one. So when we have this get, the next one that we want to implement is also a get, but for the ID. So once again, app MapGet. And here, once again, in this get, we have to specify a pattern. In this case, the pattern should be api.payments. And here, the next important thing, how can you actually bind to route params? Well, it actually works exactly like we did in controllers. The only difference is, of course, that we specify, for instance, the ID here as the placeholder in our pattern that we define for this MapGet. So in this case, then the action that we want to actually execute, it will also be an async one, and we'll also use a lambda method for that. And here we will once again need the app DbContext, but then we need actually to also get this ID somewhere. How does it work in controllers? We simply put the ID, or we simply put a param in the action method that actually should correspond to the placeholder that we have set here. So it's exactly the same also in the minimal API. Like here we can say int ID, and that should be it. Now our ID that we will have in the route will be mapped and placed here, so we can actually use it, which is fairly cool, I get. Now, of course, the way we implement this is very simple. Here in this var payment equals, and we use the context, of course, payments, then first or default async. Of course, we'll have also to put the await keyword before that, but let me first say that I want a payment for which the ID or payment ID equals to the ID that we actually get here. Let's, as said, put here an await, and here, like we would return once again results, which implements actually this iResult, or all these methods actually return an iResult. It's better formulated like that. So in this case, we just also return an OK 200, and we return this payment. And voila, we have another endpoint. Let's, for brevity, just give it a name here, because this name will actually be useful for us for the next method that we will implement. And this would be get payment by ID. So that would be the name for this endpoint that we can then reuse. Now let's go to the next step in our CRUD operations. And of course, we want to be able to add a payment. So we will go over and say MapPost. And that's it. Right now we know that if we get a post request for the pattern that we specify here, that would be API/payments in this case, so exactly like the first one, but with post in this case. Now what we want to do is, of course, execute this async, and we can specify here an app DbContext context. And here what we will need is also a body. So the question is, how do we actually get a body in a regular controller? And the answer is you can just put it as a parameter in the action that will actually handle that post request. Well, it's exactly the same also here. So we have here a payment, And yeah, let's call it just payment. Okay, so that should be it. Of course, here in this post, the payment will also contain the payment ID, but as said, this is not on a best practice on how we should use DTOs. When we create a resource, we will just don't provide a value for the ID. But actually, this is what we want to have. So let's also say here with name, and here would be the name for this one would be create payment. Good, so far so good. Now, the next step is, it seems to be a little bit cumbersome to always write here some Lambda methods. And probably in order, if we would like to keep this file clean, we would actually like to move this in some other files. But always working with Lambdas here might not be very familiar, or maybe some of the developers are not used with it. So that's why in the .NET 6 Minimal API, we actually have two different ways, or we have several actually different ways that we could use in order to provide actions to our mapping endpoints. So let's just look into one of them. And I want to show you also one very nice thing here, is that you see that here in this file, we actually don't have the program class. Now, this is actually a feature that is here with .NET 5, so it's not something new in .NET 6, and it is called top-level statements. What this actually means is that for the executable programs that you create, for the program entry point, you don't have to specify any namespace or class or anything. You can just write your code and it will simply work. So that's a feature that we have here already starting with .NET 5, but with .NET 6, this is the default that you get when you create a new project template. Now, the idea is that actually what happens behind is that this program class still exists. So the class is still there, but it's simply abstracted away from us so that we don't have to care about that. Now, if for instance, you want to extend that program class with something, well, it's nothing easier than that. So what we could do here is, let's simply say here, class, let's call it, let's make it public partial class program. So if we, of course, we have to also use the correct typos or typing. So basically, by creating this partial class program, we can hook into the program class that actually exists behind the scenes. So it's not that it is not there, it's only that we can see it. But if we need to add something to that class, well, then we can simply create this partial class here, and we can add whatever we want to this program class if we want to add something that it is not already there. And in our case, actually, we want to add something, because what we want to add here is, let's say, private async task of iResult, because we want to return an iResult. Basically, we want to move the Lambda function into an own method that we can call then when we map the endpoint. So in this case, let's call this create payment. Now, what we will need as params for this method is actually exactly what we already have here. We have this app context and the payment, which is okay, I would guess. And here in this one, that's actually very easy to implement like all the others. So we can say, for instance, just very simple context dot payments dot add, and here we'll have the payment, and then we will say await context dot save changes async, so standard proceedings. But now the interesting part comes in when we want to return, because here we want to return a 201 created. And we can do this simply by using this return results. And we have this created, which is a very simple created, but we have also a created at route in which we can actually use to also specify a location header to the exact resource URI to get this resource after you have created it. So in this one, there's actually three things that we have to specify, which is very important. And it's similar to the created at action that we have that we had also on controllers. So the first thing that we have to specify is actually the name of the action or the name of the endpoint that we actually want to call. Now, in our case, we want to call this method which gets the payment by ID. So we say that it has this name, get payment by ID. So we go back here and we just paste this here. So we are sure that we are using the correct method name. Now, the next thing that you would have to provide is actually a new anonymous object. It could be also a typed object, but let's make it anonymous, in which you can specify the routing params. Now, for the route, what we have to specify is an ID. Okay, no problem. Let's do that. So ID equals to payment dot ID, because by the time, or the cool thing here is that while we execute or while we run this program, what happens behind the scene, but here is not ID, is payment ID, and that should work right now. And of course we need also, no, actually that's everything. Good. So what I wanted to tell you is here that we actually, by the time that we save the changes, we actually get from the database the response with the updated ID that gets created by the database. So this is why we can simply access it here, and the value here won't be 0. Now, for the third thing that we can provide here when we run is we also want to provide a body that will represent the resource that we have just created. So this is usually how we do this. So we can simply, sorry, not the DTO, but the payment here in this case. So we just provide a payment. So once again, when we use this created at route, we can then specify the exact endpoint name that we have defined with the with name method. Then we have to specify an object that would contain the route params. In our case, it was only the ID. And then we can specify also the payment itself in our case, or the payload that will be placed in the response body in this case. And that's actually it. So this is everything about our method. Now let's get one step further, and I would like to show you one of the features actually that we have in the minimal API. We can bind these endpoints to static methods. So we can make this private static async task of iResult. So let's go now back here in our MapPost, and things will change slightly a little bit here, because right now we don't actually want to use a full lambda. We'll go one line down with the entire arrow, and we will say here await, and we can say create payment. Of course, the only thing that we will need to do is to pass in the context and to pass in the payment. And voila, that's it. Everything is done. And once again, we can simply say here with name, and we can call this create payment. That would be the name for our endpoint. So we already have this post. Now let's get one step further. And in this case, let's try to map the put. So for the put, once again, we have to specify a pattern. The pattern would be API/payments/ID. That would be a route param. And then, once again, async. But I guess in this case, we will already go on the next line, because we already know that we will use a method and not directly a lambda. Here, what we would need is, of course, the app DbContext. And we'll also need from the route, we will need the ID, int ID. And what we will also need is the payment. So we have payment that will be in the body. Now, once again, this is not the best practice. You would use a DTO for that, because you should take the ID from the param and then all the other properties from the DTO itself. But in our case, the payment will also contain the ID. But really, just let's focus on how we get these endpoints running. So that would be actually everything that we would need for this put. Now let's go here and create another class, because I would like to show you another way that we can actually map these methods. So let's create a new class that is called public class. Let's call this endpoints. And in this class, let's create a new method We can even say it's private because no, private not, because we will use it outside of this class. So we can say internal, for instance, because we will use it in the same assembly. So internal async, once again, task of I result. Let's call this method update payment. That should do it. Now, what we actually want here, once again, we can just copy it from there. So let's put this here, everything, and we have what we need. Now, of course, what we would do here is we would create from a DTO a payment. We will then add the ID to it. But here in our case, we already know that we have the entire information. Once again, this is not a best practice, but I want us to focus here on how we work with the minimal API. Now, here, this update method should actually be very, very easy, because the only thing that we could do here is we can say context dot payments dot update, and we just specify the payment, which would be probably an updated version of the payment that already existed, and then simply await context dot save changes async, and that should do the job. And now we have to return something. So let's here return result. One of other type of results that we can return is no content. So this would actually say that, hey, we have created or we have performed the update that you, the client, requested, but we don't return anything. We just let you know that it was successful because it is a result in the range 200. So that would work okay sometimes. And I just wanted to showcase this other possibility. Now we have this method here. Let's see how we can wire it up with the endpoint that we actually have here. So we have here this MapPut. Now what we can say here is await new endpoints. We create a new instance of endpoints and then update payment. Of course, in this update payment, we have to specify, to provide the context, the ID, and the payment. So this is what we actually need here. And that's actually all. We can just also decorate this with name. And here we'll call this update payment. And this should work just fine. So we have also implemented this one. Now, the main difference between the MapPost and the MapPut is that we actually, in the MapPost, we map to a static method in the program class. So we can map to a static method. Now in the put, we actually map to an instance method. So we need to create an instance of these endpoints, and then on this instance, actually invoke and call and run, of course, this update payment method. And we for sure need to await that. And that's it. So these are actually the three main ways that you could actually bind some action to a certain pattern when it comes to mapping to your different endpoints here. So you can just provide a lambda, you can provide a static method, or you could provide an instance method. These are the main three ways that you could actually achieve that. Now, for a full CRUD, actually we just have another one that we need to implement, which is app.MapDelte. Of course, once again, we have to specify first a pattern for that. And here in this case, it would be API slash payments and slash, and we can then also provide the ID here. And when we get this, right now, let's use a lambda because we started with lambdas. Let's finish up with lambdas. That would be nice. So we have here an async, and here we need an app DbContext, and we would also need here an int ID, and that would actually be it. Of course, the problem here is have a typo here. Now everything should work again. What we do here is actually very, very simple. It's just a delete. So let's first get the payment. Var payment equals await context dot payments. Sorry, first or default async. and we want to get the payment for which the payment ID equals to the ID that we actually get from our route. Then the next thing that we want to do is on the context, we use this payments, and then we say remove and remove the payment. Then of course we just have to persist these changes. So await context.save changes async, and to keep everything as short as possible, because right now we covered all the main things about the minimal API. We have seen how we can map the endpoints. We have seen how we can use dependency injection. We have seen how we can actually run some code when a certain pattern is matched by a lambda, by a static method or an instance method. So let's just return results and no content once again, and that should do it. So right now we see that we don't actually have any errors here, which should be fine because we need to get the application running. So let's just run that and see if everything works as expected. And as always happens with demos, you usually get errors, but hopefully this time we will not get any error. So we have a new browser window which is on the other monitor, but I will bring it here just in 1 second. Let's start here with this post because we need to create something. The database is blank right now, so we don't have anything. Now we have here for this post, we have a pair name, let's say Dan, which should be my name. We have here then a source bank. Let's call this bank A. We have here a destination bank. Let's call this bank B. We have an amount. Let's make it, I don't know, 1 point something. Could be dollars, euros, or whatever other currency you would like. Now for the datetime, we get here a value of the datetime now, so we won't change it. Let's just create this new instance right now. Or sorry, let's create this new object in the database. We should just wait a little bit, and we see that we got a response back. It's a 201 created. So first of all, we get this body. But then if we look at the headers, we also see that we got the location. So we see here that if we go to this localhost/API/payments and the ID1, we should be able to retrieve the newly created resource. So that's also a way that we can already test another endpoint that we have. So let's go to get payment/ID. Let's try it out. Let's put here the ID1 and let's execute that. And we see that we got the result. Let's also check that the get all payments works. So try it out. Here we don't have to give anything, and it just should return us an array of payments, which it happened. But of course, this array contains only one element right now. Cool. Till now, everything works fine. Let's now check the update. So we can go here with this put. Let's once again try it out. But before we can try it out, let's use the get by ID. Hopefully we still see the result here. And let's just copy here this body because we'll reuse it. We have to specify. I just want to change only one information there. So let's try it out. For the ID of the request, we know that it is 1 because we know that from the location header that we received when we actually return this. So let's here just change that instead of bank A, we want to have it on a bank C as a source bank. And let's execute this endpoint. Once again, 204, no content, so everything should be fine. Now, if we go back to this other endpoint, which we can actually go on the get all payments, and we see that it is correctly updated, which is totally cool. And then the last part of our CRUD, which is the delete. Here, once again, we know that it is the ID1. So let's specify it, nothing else that we need. Execute, we receive a 204 created, which is okay. So if we go back here and execute, we'll see that our array is now empty. So what we have achieved right now is that we have created a full functional ASP.NET Core minimal API in .NET CIS, providing full CRUD functionality for our payments resource, which I think is a fairly good thing, or I am very, very pleased with the outcome. Let's just make a short summary of what actually this minimal API is and how this minimal API should work. So first of all, the very important thing of a minimal API is that you actually don't need, or you actually could have this add endpoints API explorer. As I told you, this is not something that is only in the minimal API. You will see this method actually, or this service, in all the different project types that you have in .NET 6 or in ASP.NET Core on .NET 6, of course. And then, of course, we did add the connection strings as we had previously, and then we build the application. And how we know that we have actually a minimal API is that we have this new way of mapping our endpoints, in which we can simply say we want to map to a get, we provide a pattern, and we provide actually a method, a function that we want to execute when this pattern is matched for a certain request. And here we can use some methods to define some further metadata about the endpoint, like the name, which should be unique. We can then say what this endpoint produces and things similar to that. And then, of course, we could use as the method or as the action itself, we could use a lambda expression, which we did here for these two endpoints. But then we have other ways to do this. We can use a static method. In this case, we have a static method on the program class, and we have seen that even if we don't have explicitly a program class here in this minimal API, we can just use this partial class program and add the functionality that we need to the program class. In this case, it was just a static method that we wanted to execute when we had the post for API payments. But then we can use also instance methods, and here we have this new endpoint. So we get a new instance of the endpoints class, and on that instance, then we call this update payment method that we have created specifically for that. And that's basically it. And I told you at the beginning, or at some part of this video, that maybe at the end we'll do some magic to, let's say, take away all these usings here. And that's actually a very, very cool thing, because that's something new in .NET 6. We can simply add here or use what we call global usings. So let's go here, for instance, in the minimal API and create a new class. Now, how we name the class is really not important at all. In our case, I'll call it global usings. Now, this will add a class. For the global usings, the cool thing is that we don't need anything here. So it can be totally blank. Now let's go here in the program file once again, and let's cut everything from here. So we don't want any usings to be present on our program file in this case, or for the matter in none of the other files. So let's go here in this global usings and let's paste everything here. But let's also use this global keyword. And you see that while we use the global, they get white, so not gray anymore, which actually means that those global usings work. So if we go right now back to the program file, voila, no error. And we did get rid of all the usings that we had everywhere. Now, if we go to the app DbContext, I guess we can also get rid of that, because those should already be there. As you see, no error once again. And I guess that's the only other place where we have added usings. So once again, in this global usings, we use this global keyword before the using. You can specify the usings in one file, and they will be used then throughout your entire project. And you don't have to clutter your files with a bunch of using statements at the top of it. Because in real applications, the list of usings could become quite large. And this, from my point of view, is also a very, very nice thing. This being said, thank you very, very much for watching. If you did enjoy this content and if you find it useful, don't be shy and hit the thumbs up button, or of course subscribe to the channel if you didn't do this already. And if you think that you have colleagues or friends or whoever that might also benefit from this content, then just please feel free to spread the word and share the information about this video, because if it helps, then I guess that they will be thankful to you. And since this is a very, very new feature in the .NET 6, probably you have a lot of questions or thoughts or things that you maybe want to discuss about regarding the minimal API. Once again, don't be shy. We have a comment section here on this video, so use it. I would be more than happy to get in touch with you and get to talk about the minimal API, the pros, the cons, and how we can really use it. Once again, thank you very much for watching, and until the next time, I wish you the very best.